Hello and welcome everyone to the quick solutions of All India AIATS Test Series Medical 2019. Test number 14, code A and B, dated 9th May 2019, and I am here to discuss the physics portion. So let us get started everyone. Let us move on to the question number 1. So here is question number 1 everyone. The position vector of particle moving in a plane is given by vector r equals 3t square I cap plus t cube j cap. The ratio of magnitude of tangential acceleration and centripetal acceleration at t equals 1 second is given by, where r is in meter and t is in seconds. Now, considering this as a part of motion, here is the particle at any instant. So this is the direction of tangential velocity, or this is the direction of velocity at this moment. Direction of tangential acceleration will be same as toward the velocity of the object. This is the net acceleration A, we can say, and here will be the centripetal acceleration or radial acceleration. We know very well the radial acceleration is perpendicular to the tangential one. Now r is given, vector r is 3t square I cap plus t cube j cap. Now differentiating, we will get the velocity vector v, that is 6t I cap plus 3t square j cap. Differentiating once again with respect to t, we can get the net acceleration vector a, that is 6i plus 6t j cap. At t equal 1 second, we will get the velocity and acceleration respectively, that is v 6i plus 3j cap, a 6i plus 6j cap. The magnitude of acceleration from here we can write 6 under root 2 meter per second square, that is obvious. Velocity 6i cap plus 3j cap. Now we have to take the ratio of tangential acceleration with respect to radial or centripetal. This is what we need to find out. Now AT we can write, suppose this is angle theta, therefore AT will be what? Net A into cos of theta, and this can be written as, here AT is one of the component of A, so we can write AT as vector A dot AT cap, where AT cap we can calculate from velocity vector, because the direction of tangential acceleration will be same as the direction of velocity vector. So therefore vector A, that is 6i plus 6j dot AT cap will be given by v cap, that is 6i plus 3j whole divided by under root 45, and after solving we will get this value as 54 upon under root of 45. So here we have got AT as a cos theta, or AT will be what? A cos theta, that is 54 upon under root 45. Let's calculate cos theta from here. Cos theta will be 54 upon under root 45 multiplied by magnitude of A, that is 6 under root 2. And after solving, we will get cos theta as 9 divided by under root 90. Let us complete the triangle from here. Theta, cos theta base upon hypotenuse n, that is 9 under root 90. Here it gets you under root 9, that is 3. Now what will be AC? If AT is a cos theta, then AC, or you can say AR, will be a sin theta, which is equal to, now taking the ratio according to question, gets you AT upon AR, that is a cos theta upon a sin theta, that is cot theta. From the triangle we can easily calculate the cot theta, that is base upon perpendicular. 9 by 3, that is 3. So from here we have got the ratio of AT and AR, that is 3. So option number 4 is absolutely correct. We will go with option number 4. Now move on to the next, that is question number 2. So here is question number 2, everyone. Wire of conical shape of length capital L and radii A and 2A is stretched by two forces F applied parallel to length in opposite directions normal to end faces as shown in figure. If Y denotes Young's modulus of elasticity, then extension produced will be what? See, here the areas, cross-sectional areas are different. We know very well that the extension delta L is given by applied force, actual length upon cross-sectional area into Young's modulus. Now first of all, area, cross-sectional area is changing gradually from 0 to L. So that's why we need to put effective area here, and in this case is the effective area we can write under root of A1 and A2, where A1 is this area and A2 is this cross-sectional area, which is equal to A1, that is pi into A square, A2 which is pi into 2A square. Now area effective we can get pi into 2 into A square. Now let us solve it. Delta L is therefore F as it is, L as it is, area effective, that is 2 pi A square multiplied by Young's modulus. So this is our final answer. Now let us check the options. After looking at the options, we can say that option number 3 is perfectly matching. So we will go with option number 3 only. Now move on to the next, that is question number 3. So here is question number 3, everyone. A speed of planet at apogee in terms of eccentricity E is, where A is semi-major axis of ellipse and M is the mass of the sun. Now we can consider the situation something like, suppose this is the path of planet where here is the sun. In case of apogee condition, this is geometrical center we can write, and this distance is called as A. The total energy ET can be written as minus of G capital M small m upon 2A, equation number 1. This is the total energy we can write. Now in case of apogee condition, this is here the sun and here is the planet having mass small m, here is mass capital M. The separation will be what? The coordinate of this focus is given by minus AE0. If you are saying this as origin, then this will be minus AE and 0. Means this distance is AE and this much distance is E. So the total distance R comes AE plus E. Now energy will be same as total energy because the total mechanical energy is conserved in the motion of planet. So therefore the total energy in this case ET dash will be given by potential energy minus GMM upon separation, that is AE plus E, and it will have kinetic energy as well. If speed is V, then kinetic energy half small m V square. Energy always conserved, therefore ET will be equal to ET dash, and that's why we can write minus GMM upon 2A equals minus GMM upon AE plus E plus half mv square. Small m will be cancelled out throughout, and after solving this particular equation we will get the value of speed in terms of small e, and that speed gets you v equals under root g capital M upon a within bracket 1 minus e upon 1 plus e. So here is our final answer. And now let us find out the options. After looking at the options, we can say that option number 2 is perfectly matching, so we will go with option number 2 only. Now move on to the next, that is 4 number. So here is question number 4, everyone. A bucket contains water filled up to height 15 centimeter. The bucket is tied to a rope which passes over a frictionless light pulley, and other end the rope is tied to a mass which is half of the mass of bucket plus water system. The gauge pressure at the bottom of bucket will be what? We have to take G equals 10 meter per second square. Now let us solve it. According to question, we are having a situation which I can show you in the diagram. Pulley, bucket and water system. Suppose the total mass of this system is capital M. Another side, another object of half mass is suspended. From the diagram it is clear that this system goes down with acceleration a. Similarly, this mass goes up with same acceleration a. Writing the equations using Newton's second law, we have mg minus t equals ma and t minus mg by 2 equals ma by 2. This is for bucket water system, this is for mass. From here, if you solve, we will get the value of acceleration, that is g by 3. Now this whole bucket is moving down with an acceleration a. So the effective gravity at the bottom can be written as g dash, which is g minus a. So effective gravity now change. The pressure due to the liquid at the bottom of container, at the bottom of bucket, can be written as delta P equals rho G dash into H. Putting the value, density of water 1000, G dash, that is G minus G by 3, or you can write 2G by 3 multiplied by H, that is 15 centimeter, or you can write 15 into 10 to the power minus 2 meter. We have to put SI systems. Solving it gets you delta P equals 1 kilopascal. So this will be the pressure at the bottom, gauge pressure at the bottom of the bucket. Now let us find out the option. We can say that option number 1 is absolutely correct, so we will move on with option number 1 only. Now move on to the next question, that is 5th one. Now here we have question number 5. A radioactive material decays by two processes A and B with half-life 0.5 hour for process A, 0.25 hour for process B respectively. Assume for the first half hour it decays only with process A, with next 1 hour with process B, with next half hour it decays with both A and B process. The original number of atom in the material was N0, then after 2 hours the number of active atoms in the material will be what? The question belongs to nuclei chapter, and we know very well after n half-lives the quantity remained will be given by n equals N0 1 by 2 to the power n. The question will be done with this particular concept. Now let us start from t equal to 0 to t equal to 1 by 2 r. The decay is done by process A, okay, which has half-life 0.5 hour. So time is 0.5 hour and half-life is also 0.5 hour. It means the quantity remained will be what? N given by N0 divided by 2. Now let's talk about the next 1 hour process, that is t equal to 1 by 2 to t equal to 3 by 2 r. Here the decay is done through process B, which has half-life 0.25. So the time is 1 hour and half-life is 0.25. That is t half. It means the number of half-lives required will be what? 4, and the quantity remained is given by n dash, that is Initial means for the beginning of this process, that is n0 by 2 multiplied by 1 by 2 to the power number of half-lives, that is 4. Solving it gets you n0 upon 32. Now let us talk about third process, that is from t equal to 3 by 2 to t equal to 2 hour. The total time here is what? Again half hour. Time is 1 by 2 hour. Here the process required is combined A and B. So we have to take the effective half-life period. So T effective for third process will be given by T1 T2 divided by T1 plus T2. After solving, this value is 1 by 6 hours. Now the number of half-life required will be what? 1 by 2, that is time, divided by T half, that is 1 by 6, which is equal to 3. So amount of quantity remain is given by n double dash, that is initial, means at the beginning of this last process, that is n0 upon 32, 1 by 2, number of half-lives, that is 3. After solving, this n double dash will be n0 upon 32 multiplied by 1 by 8, and ultimately we will get the value as n0 upon 256. So this is the final answer, and after looking at the options we can say that option number 4 is perfectly matching. So we will go with option number 4 only. Now move on to the next, that is 6th number.